Alright, hello and welcome. This is the Collision Lab tutorial, just kind of showing you how to analyze your data. So what I have here is a collision of two carts. We got cart 1, which ran into cart 2, which is in blue. So cart 1 is in red, cart 2 is in blue. And as you can see, cart 1 ran into cart 2 with some velocity. We've got a slope on this position versus time graph. Slope of position versus time graph is velocity, and cart 2 was at rest in this case before the collision happened right here, and it caused cart 2 to change its velocity to whatever this slope is, and cart 1 changed its velocity to whatever this slope is. So the collision happened right here, and here we get changes in slope here, and there you go. So what we want to see is if momentum is conserved. If that's the case, I can take the mass of cart 1 and multiply by the velocity of cart 1. That will be the momentum at the beginning. And then the momentum at the end will be the mass of cart 2 multiplied by the velocity of cart 2 added to the mass of cart 1 multiplied by the velocity of cart 1 after the collision. So in order to get the velocity of cart 1 before the collision, what I'm going to do is I'm going to highlight this part right here. This will be before the collision. I want to do it just before the collision happens. It's very important. I want it just before the collision happens, so I highlighted just before the collision happens. Then I'm going to go to Analyze, Linear Fit for only cart 1, and it gives me a best fit line for cart 1 right there, and it gives me an equation with a slope, so that's my velocity right there. After the collision, I want just after the collision to see what that new velocity is going to be, so I highlight just after the collision. Again, this is where the collision happens. You can see because those changes in velocity that happen. So I highlight just after the collision happens. Again, I go to Analyze, Linear Fit, so I'm going to get the slope of those things. That's for cart 1 and cart 2 in this case, because I know cart 2 is now moving where before cart 2 was at rest. So I get that, and I get so for cart 1 I can put that off to the side right there, and cart 2 right there, and I can take the slope, which is the velocity for cart 2 and the velocity for cart 1. Take the masses for cart 1 and cart 2, add those together for their momentums, and then I could take the mass of cart 1 plus the velocity of times the velocity of cart 1 to find the momentum before the crash. And so if I take those momentums, hopefully this momentum will equal the sum of these two momentums. If that's the case, then the momentums are essentially conserved. Thank you, and let me know if you have any questions. All right, bye-bye.